Dear students, today we will solve the fourth numerical from chapter number 4. This is physics class 9. The numerical states that a seesaw is balanced with two children sitting near either end. Child A weighs 30 kg, sits 2 meter away from the pivot, while child B weighs 40 kg and sits 1.5 meter from the pivot. Calculate the total moment on each side and determine if the seesaw is in equilibrium. Dear student, this is one child and let's its weight is 30 kg and he is sitting from this pivot point at a distance of 2 meters. And second child has a weight 40 kg and he is sitting at a distance of 1.5 meters from the pivot point. This is the pivot point, 1.5 meters. Dear students, one thing we must know that usually the mass and the weights are different. In this question, they have stated that the weight is 30 kg and the 40 kg. These are the masses. Okay, weight is the force with which the earth attracts a body toward its center. So these are not the weights. If in common life we say mass and weight as alternative, but in physics we should be careful while writing the units since it is written kilogram. So kilogram is a mass, not weight. Here also is 30 kilograms, so it's 30 is a mass, not a weight. So I will write here as masses. So mass of the first child, if I represent this by m1, it is 30 kg and the force which it will be exerting on the seesaw, if I say it is F1, that will be equal to its weight, and the weight can be calculated as multiplying mass with the gravitational acceleration. Since the mass is m1, I will write here m1. So mass is 30 and multiplying it with the value of g, which is 10. So it will give us 300 and Newton. So the child which is sitting on the seesaw on the left side, this one, is exerting a force of 300 Newton on the seesaw. Let I represent this weight as W1. And its distance from the pivot point is 2 meter. So I will write this distance as L1. This is also called the moment arc in physics terminology, and this distance is 2 meters. Now we consider the second child. Its mass is, if we write it as m2, then this is equal to 40 kg, and the force with which it is pressing the seesaw downward will be equal to its weight. I represent this with F2, second force, and with this will be equal to weight W2, and weight is mass multiplied by g. This is m2 and multiplied by g will give us the weight of the second child, and since its mass m2 is 40, multiplying it with 10, the value of g, it will give us 400 Newton. So its moment arm, that is distance from the pivot point, is L2, and this is 1.5 meter. In the figure, we have also mentioned here that the distance of this child from the pivot point is 1.5 meter. So we have to calculate the moments on each side. This is given that we have to calculate moments on each side. So the moment and the torques are the alternative words. We can write it as moments, or we can write it as torque, or we can write it as also the turning effect. Moment of 30 kg child since the moment or torque are alternative, so we say it as tau 1 first torque, and it will be equal to F1 multiplied by L1, and the value of F1 is 300 Newton, and the value of L1, that this moment arm, this is 2 meter. So multiplying 300 with 2, it will give us 600, and the units for torque from here, it will be Newton meter, Nm. Similarly, we also calculate the moment of 40 kg child. If I write it as tau 2, then it will be equal to F2 and multiply by L2. Here F2 is 400 Newton, and multiplying it with 1.5 meter, it will also give us 600 Newton meters. It means that both the moments, that is moment of 30 kg child and the moment of 40 kg child, are same, that is they are 600 Newton. Also, since the moment of 30 kg child is anti-clockwise and the moment of 40 kg child is clockwise, and according to the principle of moments, if the clockwise torque and anti-clockwise torque both are equal, then they are balanced and none of the body will rotate, and the system will be in complete equilibrium. I repeat this one. There are two children which are sitting on the seesaw. Let the mass of the one child is m1, it is 30 kg, and the force it will exert on the seesaw is F1, and the formula to calculate force here, it will be equal to its weight, and it is m1g, multiplying m1 with value of g10, it will give us 300 Newton, and its moment arm is L1, it is 2 meter. The mass of the second child is 40 kg, and the force it will exert on the seesaw will be equal to its weight. So F2 will be equal to W2, and W weight can be calculated as multiplying its mass with G. Mass is M2, which is 40, and the value of G is 10, that is 400 Newton will be its weight. And its moment arm L2, which will be equal to 1.5 meter. So to calculate the moment or the torque, we will use the formula tau is equal to Fl. So tau 1 will be equal to F1 multiplied by L1, and multiplying 300 Newton with 2 meter will give us 600 Newton meter. And also calculating the torque of 40 kg child, we will also use the same formula, but here tau 2 will be equal to F2 multiplied by L2, and 4 Newton multiplied 1.5 meter will be equal to 600 Newton meter. Since both the torques are equal, so they are in the equilibrium. Thank you very much for watching this video. See you next.